Well, thank you, Randy. I appreciate it. And yeah, no, happy to share these, and happy to always contribute. So this is a talk from NWA, and it's also largely, if some of you remember, I sent out a survey to all the Central Region students asking all of you to respond back about your own thoughts and feelings about probabilistic data impacts on you. So that's really why I also wanted to bring that to the entire region, because this presentation was built largely upon your input and your feedback. So it's not just all my own opinions here. This talk is not a nuts and bolts probabilistic talk. It is more of a philosophical talk. So maybe that's a good thing, maybe that's a bad thing. We'll find out. So alrighty, so right, there's a lot out there, very data rich, and we're only showing the NWP examples, right? So there's a lot of options out there, probabilistically speaking, not only just in data sets, but also in techniques, right? There's, various different flavors of visualizations, different techniques, approaches that are being employed, and, so is that a good thing? Is it a bad thing? That's one thing that we'll kind of, get into, or is it really a mix of both? But right, we're in this data-rich environment, which has seen this expansion of probabilistic tools and data sets. And so, kind of my thought maybe about a year ago, I don't remember when I started this, this idea for this talk was, okay, what's the impact on, who we are as forecasters, our process versus production and things like that. So we'll get into that, right? So there's good and there's bad, and there's a mixture of both. So the good, yeah, and there's nothing new here, right? The probabilistic data sets really challenges our deterministic way of thinking, and helps to provide context in regards to predictability in the spectrum of solutions. And here's two examples here from surrounding wonderful Lake Superior of an HRIF example up top with the PMM and then the WPC super ensemble, and really being able to break apart the various spectrum of the solutions, provide some sort of context, some sort of clustering, not just following the mean, but following things maybe in a little bit more intelligent way. It takes training though, right? It's something that we've put an emphasis on ahead of these big events, is trying to share out science sharing to our staff to break down some of these tools. And okay, the visualizations are great, the colors are pretty, and wow, but what do I do with it? And that's something that is always the challenge that I find myself when I give some of these science sharing things. I throw like 50 sources at everybody and look at this, look at this, look at this, look at this. Well, okay, what are we going to do with all that information in the end? So yeah, it definitely takes a concerted training effort to make that connection from these great visualizations or just 50 tools. Okay, this needs to actually have some sort of impact in the process, or do I know where to implement this, right? Yeah, so I briefly mentioned this, right, is acknowledging the challenges. It's a training issue, a competency issue. There's a lot of data sets out there, and there's a lot of approaches that they all employ, and trying to know how to correctly employ them and being able to teach all of them is a challenge. Part of it is, do you need to look at all that? No, pick out your 3 or 4 things that really click with you, and run with those. I mean, that's part of, I think, it too, is that not to feel like you have to look at every single chiclet and every single plume and every single flavor of probabilistic data sets, because you just can't. There's so much out there. So pick that handful of things that really work well for you, and run with those, because otherwise it will be data fog. There's a lot out there. There's kind of this, the big kind of question is, how do we fit this probabilistic peg into, for the most part, largely deterministic hole still in our forecast process? And that's something that we'll discuss a little bit more through the talk. A lot of people talk about, well, GFE, it's very deterministic. What do we do with it? How do we need to change it? So we'll touch on that. And then there's the question of IDSS, in which, the answer is not just one thing. There's an undeniable segment that just want a number. And that's okay, that's what they want. And there's a segment, undeniably, that wants the higher level amounts of data probabilistically. So yes, the probabilities can give more context, right, to those who just want a number. But there are certainly those who still just tell me how much snow is going to fall, right? And that's a challenge. If we can give them that number, but we can also take the opportunity to provide a little bit of a flavor of context and probabilities without going too deep into it. And we don't have to overcomplicate the probabilities either. A lot of the studies out there show that the public actually has a better understanding, and at least in a general sense, of probabilities. So it doesn't have to be complicated either. There's also the human aspect of it. Everyone on this call has for the most part, different personality. And that probably really influences how much data is required for you to make a decision and what type of data to make a decision. That's going to be different for me than it is for you. And therein lies the challenge of probabilistic versus deterministic, fitting them together with conceptual models and then putting that into some type of a process. And then quite tangibly, what does probabilistic data mean for me in regards to my role as a forecaster and forecast process versus forecast production? And we'll touch on that in a second. So there's various, I think, questions that we're trying to answer by time scale, and this is a very nuts and bolts, I guess, probabilistic questions. And there's nothing new here, right? Days 5 through 7, the question you're trying to answer is this thing even going to hit my region, right? And then we try to step it down from there in days 3, 4, 2, 1, and then trying to eventually just land the forecast, and within a spectrum of solutions and how this is going to vary in time and space, and are there any failure modes and conditional scenarios. Those are all great kind of, abstract questions maybe. But I think in winter, the question we're really trying to answer out of all this probabilistic stuff is, when do I go with the snowfall map and which flavor? That's the question behind the question. That I think we really kind of battle with, especially as we move into winter, is this snowfall map question. When do I go with one? What type? And so, and the probabilities can help us in that, but so can the conceptual models. And so this will warm the hearts of those who are big fans of the foundational science. You can probability yourself into just about anything, right? And so we have to remember it's a both and of probabilistic fields and the conceptual models. That conceptual models helps to give somewhat of a lens to the probabilities, right? But the conceptual models, which you're probably generally employing on a single data set, don't have the full spectrum of all the rest of the uncertainty that is out there, right? So we can't go over on statistician, right? Because we need to bring with us those conceptual models from that are who we are as meteorologists, but we can't be pure meteorologists either. We have to, take advantage of those data sets probabilistically. That helps to probably get us to a much more better space in realizing where we are in a predictability. So touching on predictability, I think sometimes we often know a lot less than we think we do, right? So this is just for snowfall. And just as a random list on the left, and the list goes on and on. Think of all the things that could go wrong with your snowfall forecast. Forcing, scales, types, alignments, thermodynamics, microphysics, for us, terrain and lake effect. The dreaded dry slot, which will ruin any of your snowfall forecast when you wake up in the afternoon on a midnight shift and you peek out the window and there's no snow yet, and it kind of ruins the rest of your day. I've been there. And then finally QPF, which is kind of the final, the final reflection of everything else. And that's just a small list of everything that can go wrong with your forecast, right? And so I think a lot of times we think we know more than we do, and our predictability is not as high as we actually think it is. And so that's probably where some of the probabilistic information can help to kind of make us take somewhat of a step back. The conceptual models gets us in this general reference frame of where we are, but then from that we need the probabilistic data to kind of help us to acknowledge, yeah, well, I really am not as certain about all those things as I really think I am, right? There's a lot that can go wrong in your snowfall forecast. And kind of planting your flag too early, which I've done and at times encouraged. Do we really have that predictability or not? It's dependent on the scenario, right? Is it a Colorado low? Much different than a rapidly propagating clipper with a frontogenetic band. And so you're going to view the probabilities a little differently in all that. And finally, we'll be done with my own opinions, but forecast production versus forecast process. This is not my own idea. I stole it from one of my very well-respected Sioux in the Great Lakes subregion, and they know who they are. Forecast production versus forecast process. So this was his idea. There's really a place for both, but where are we planting our flag? Whether that's as a region, whether that's as you yourself sitting there in the operational chair. Are we planting it in production? Well, that's the production is really just letting the forecast gears do what they do best and work through the data, turn out forecast products, right? There's a place for that, right? There's a lot of data. There's a lot of things that the machine can feed the machine. But if we planned it in more of a process that we're not, my flag isn't planted so much in the production as it is the process. And I think that's production fused with judgment, and that was, where's value in all of this AI? Well, it's, as a human, it's in your judgment. That was from a NWA talk a couple of years ago from one of their keynotes. So, are we planting our flag in process, which is, hey, using production where production does things well, but knowing that my value and the value of all this is realized in the judgment part of this, which is, again, the process. So, and a bigger philosophical things, kind of maybe take some time, think about that today, discuss it on shift with your fellow colleagues, because we're just kind of in this spot where we're kind of caught between a lot of things tugging and pulling at us, right? What's the role of the forecaster? How do I employ probabilistic data? How does this interact with legacy products and software? It's big questions, right? And so have a conversation. All right, now to get to what you guys all said. So I sent out a survey, and 56 responded, which I appreciate. Otherwise, I really would not have had to talk. So, and basically trying to get at what is the probabilistic data impact on the forecaster. So 56 respondents, not too bad. The first question that I asked of all of you was, what forecast time ranges has probabilistic information given you the most benefit to operational decision making? And it's kind of a normal distribution there, and largely in the medium range, right? And it makes sense. That's where we probably, it's probably the quickest win for the probabilistic data, because by nature we know that, I shouldn't be overly deterministic there. So it's a little more natural to use the probabilities. As I think the tougher part is as we move into really the critical grid periods, or that first 0 to 12 or however many hours, is you got to land the forecast from a probabilistic. At some point, the forecast becomes deterministic. Something's going to happen. And kind of making that, transitioning through that is a challenge, right? And that, I think, probably came out of some of the test beds for sure, whether it was dealing with NVM pouts or ESTF things. Hey, it's a challenge, and that's not a bad thing. It's an opportunity, right? And then going way out into the subseasonal stuff, that's going to be definitely more and more of an emphasis. But it's, I think, more of just training. I mean, it's certainly diving into a different areas of expertise as we move into subseasonal IDSS. So it's very data rich out there, but I think we're still trying to find our way at the WFO level, exactly how to employ some of that subseasonal stuff, which more will follow on that. Second question was what's your effectiveness to translate probabilistic signals into gridded forecast modifications? So very difficult on the left, very easy on the right. And I was actually surprised. I was, for the most, it's kind of skewed a little bit more towards very easy to accomplish, but there's kind of this, almost half that are kind of in the middle to, further on to the left there, which is, a little bit more of a difficulty in translating probabilistic data sets into a deterministic GFE framework, right? So that's something that we're going to have to, look at it as we continue to move forward. Is it a GFE thing? Is it just the way we approach things? Is it, what is it? And that's going to be something to discuss further on. A little bit more ease on translating these probabilistic signals into external messaging, DSS, whatever, social media. Definitely the overall theme is that it's easier to translate it into that. I'm not trying to fit it into a grid. I can make some sort of graphic that I can push out, and it's going to take some effort to explain things, maybe. Maybe not. We should give, the public does have a little bit better understanding of 20% versus 80%. But overall, it's a little more easy to accomplish just translating these probabilistic data signals into some type of external messaging. Another question was, really trying to get at, there's kind of this big push of getting back to the basics and the foundations of, nuts and bolts meteorology, hydrology, climatology, all that good stuff. So how has our probabilistic data sets impacted our ability to employ those? And it's actually kind of good to see that on the right is where we have more reinforcement or value added, and we're really skewed more in that direction, which is good to see. But the work isn't done yet. There's still, about half or so, which is, kind of a little bit more in the middle to, maybe more of a struggle of how do I kind of marry up the foundational with the kind of these probabilistic data sets and way of thinking. I asked about confidence. What's your confidence in using increasing amounts of probabilistic data sets and tools? And this is a little bit more all kind of spread apart, right? That we have kind of this wide distribution in confidence in employing these probabilistic data sets and tools. Whether that's from just there's so many of them and so many different processes and approaches, and that's certainly probably one thing, and that's being addressed in the probabilistic training series that we kind of had the first push up, and now we'll have more of an applications approach. So that's something we'll continue to build on. Whether it again deals with, well, how do I get this into a grid, and do I necessarily have to get it into a grid either to really make a difference in the message that goes out. So we see kind of this wide range in confidence across the forecasters in being able to use all these data sets and tools. I believe one of the final things I asked, at least in a kind of a bar graph slides standpoint, is where's the probabilistic data demand the greatest? Is it mostly internal? Is it trying to feed our own processes, tools, and decisions? So that's on the left. Or is there a bigger data demand from the outside, feeding IDSS processes, tools, and decisions? And it's kind of, the perception is that it's skewed, at least at this point, more towards the internal. That where is the probabilistic demand coming from outside? Or is it right now we're really kind of just driving our own tools and decisions and really trying to understand how to use all that, which for the most part makes sense. The demand may not necessarily be as much from the external. There may be more of, kind of wanting just a number, but at the same time, we can still, increase their awareness of actually what is out there probabilistically. And again, that's an opportunity for outreach and interacting with our partners to show them, what is available, and it's not as complicated as it may first appear, right? So It's just kind of interesting to see where everyone feels the demand right now is coming from probabilistically. So we had a bunch of free responses, and I'll share some of those. So the first one was, how has probabilistic data helped you? And I'll throw them all up there. And these are your responses. And it makes sense, making anomalous events more clear and giving more confidence to go in different directions. Looking at this range of possibilities instead of just getting fixated on a specific number, which I've been guilty of. Being able to put a number to your thoughts, right? Instead of just, slight chance, which is somewhat nebulous, that you can actually attach something to it. And a new way to communicate the forecast, new language. When there's a lot of spread, that can be recognized, and then it's like, it forces you to have an understanding of what is making the forecast complicated, and from that, making a game plan. So I thought that was pretty interesting. This is also one that I think kind of gets at the heart of some of the questions of, how does this fit in my forecast process? Some may say that it hinders their ability to edit grids in GFE, but probabilistic data isn't about making database edits. I thought that was pretty enlightening, right? The probabilistic data, it doesn't have to require a forecast grid edit, which is just one grid, and it is hyperdeterministic just because it's one grid, right? There is value in the process, in the forecast process again, by allowing the probabilistic data to feed our message in ways just beyond a single grid, right? Maybe it's an outstanding social media graphic. Maybe it's interacting at a higher level with a certain subset of partners, and that's great. How has probabilistic data hurt you? There were probably an equal amount of answers on this one. The spin up time has been challenging. It's difficult to keep up on everything. I get it. That kind of initial chiclets that we showed, there's a lot of data and a lot of different methodologies, right? We're trying to address some of that. Data fog and overload. One that was kind of really interesting is this person said, I don't know how to question or challenge ensemble or probabilistic output. I want to be able to dismiss a member and say that it's not the right thing to look at. I feel I often have to take things at face value, but I know that I have the meteorology background to do better. I just need help on how to use that. What an honest answer, right? Really great stuff of, we look at these tools and, well, how do I question that? How do I try to poke holes into it? And how do I know if I poked a hole in it? At the same time, how do I use my meteorological background, to inform my, kind of venturing into my, statistician, space, not forgetting one for the other, but marrying the two together. And I thought that was really honest, really, really interesting of, how do I question the probabilistic or ensemble data? I mean, sometimes it's hard enough to question the deterministic data. Why does the her have what it has? I don't know. I mean, the her has what it has because it has what it has. It's doing things that I can't do, in a sense of trying to assimilate all that data and run all those equations. So why does it have what it has? Could be 100 reasons, right? So sometimes it's hard to even challenge the deterministic data compared to, how do I challenge, 50 ensemble members? Again, GFE and marrying deterministic and probabilistic. This person, again, very honest, I love it. Frankly, there's still a need for deterministic forecasts. No doubt, right? There's always, it's a both and. Not everything's probabilistic, not everything's deterministic. There's still those who want a deterministic forecast, there's still that space for a deterministic forecast. We can work on, trying to figure out the best way to marry those together and kind of how do we transition between the two of them. And so rightfully so, honest, and I agree, there's still a need for deterministic forecasts. And then they end with, there's a lot of options to look at as a forecaster, and adding more options doesn't necessarily mean better, right? And so we already have a lot out there, and so do we need more, or do we just need better? Do we need to condense it down? I think it's a valid question. It's tough to translate deterministic, probabilistic data into deterministic GFE. Yep, it's certainly a challenge, as much as it doesn't require a database edit, but at times, how do we work between the two, right? And then this person just says it puts too much emphasis on low probability outcomes. All right, so I try to make a couple word clouds, right? And these are from asking all of you, what two elements has probabilistic data helped you the most? So there's some big winners in there. Temperatures, snowfall, and its various flavors of wording within the word cloud shows up a lot, and that makes sense. We're kind of several years into our probabilistic, dealing with probabilistic snowfall. So that's kind of a makes sense that we're probably at least a little more comfortable with that and how to employ it probably, and POP and QPF are kind of always been the leaders in where we've tried our probabilistic approaches. We see p-type in there, which is interesting. When we move to where has the probabilistic data hurt you the most or not helped the most, there's actually some overlap here, right? So we see POP, QPF, and p-type, right? Where they kind of show up equally in where has the data struggled and where has it helped the most, which I found to be interesting. But the big one here is wind. Wind speed, wind gust, however you want to say wind in the word cloud, that it's been fairly consistent. That's a lot of feedback we hear is that the wind especially is it's just one of those grids where the probabilistic data probably has struggled, and there's help on the way with version 4.1, which Andy was talking about this morning on the CR briefing. And then p-type shows up as well too. And certainly p-type has always been a tricky thing. And again, help on the way of version 4.1. There's more innovation is on the way with that. So acknowledging that some of the stuff is still in its infancy, right? And it takes time. That's part of the innovation process. But it was kind of interesting that similar elements where people have thought that it helped the most, there's a pretty significant portion that seems like it has struggled. But wind for sure has been a common theme, and then kind of some of the smaller scale stuff like lake effect and things like that. All right, so I asked, okay, time to dream. You design this forecast system, you can do whatever you want it to do for you. Think big. All right, so what did you want? Well, one question that's always come up is, well, let's just completely overhaul GFE. Okay, I mean, I won't lie. I mean, I've had that thought too. What are we going to change it to? What does that look like? Is it, does GFE need to change, or just our way in which we use it as a tool need to change? Is it the software? Is it the forecaster? Is it the process? Probably a little bit of everything. But that's been a question of what is the future of GFE in all this? And I don't have the answer to that. It'd be great to have all this information in one location, right? That's always been kind of the challenge here in AWIP's GFE, or maybe just even some of the cloud-based stuff. But that kind of demand that let's just get this all into one place so I can more easily interact with things. I'm not trying to go from my PC to GFE and they're not talking to each other here. Absolutely, I get that. And this comment here dovetails on that. Viewable in AWIPs, able to inform GFE, available in the cloud, and we're moving in those directions, right? We are getting there, especially with the WSUP. Having the forecast take into account antecedent conditions, to help inform drought, red flag, blizzard conditions. What's my snowpack? What's my fuels? Trying to get more of that infused into the forecast system. That was interesting. Having the forecasters be able to set the thresholds across the domain so that I'm not stuck at the probability of whatever inches of snow, that I can kind of more intelligently set that to where I want. And then the final thing is, do we need six different products or graphics to say the same thing? And that kind of maybe gets to, we have all these data sets out there. And I've been guilty of that, where I've thrown in my science briefings to my staff where I throw like 5 to whatever plus tools at them, and they're all kind of saying the same thing, which I guess should give you more confidence. But do we need 5 things to tell us the same thing at the same? Anyways, that's a good question, right? So I mean, I'll leave you kind of with this, quote, which actually takes a few slides to get through. it's a both and of computer system, which is forecast production, and forecast process, which is you as a human and your judgment, which only you can do as a human. That the biggest advancement of all this would be a redesign and refresh of the forecast funnel. Don't have to throw it all out. There's certain parts that need to stay, but a little bit of a redesign. The goal of all this process is not to make an edit in a database, and maybe I would qualify with that with all the time. I mean, certainly there's time and place for making database changes, but more to focus, using the process to focus where to focus our attention. How do we provide context on predictability to ourselves? Understand, what are those key features responsible for the predictability issues, and that's nuts and bolts meteorology. That's not so much the probabilities. And from there, what's this plausible range of outcomes? Acknowledging at the same time that at some point you got to get the forecast out of the ground. The wheels got to get it out of the ground. So could a database edit be required? Maybe, this person says. And I agree. Maybe it's an outcome of the process, but it's not the main focus. There's always been big, the bigger buzzwords is, blending the meteorologist with the statistician. I think that's fair. I don't think we want to completely replace one with the other, right? Because we need the conceptual models to inform our predictability, the probabilities to build that out, and then kind of the meteorology to bring it all back again, right? So again, it's not just about this focus on deterministic GFE output. I mean, that's not where the answer is. At least I hope not. So what's the takeaways of all this? What is the impacts on the forecaster? No doubt there's an edge to the benefits, right? Opening up the spectrum of solutions, helping us to bring context, uncertainty. But there's no doubt challenges, right? It's still in its infancy. And that's just where we are, and that's okay, right? How do we visualize, interpret, and interact with the data? Is maybe less more. Forecast process versus forecast production. There's legacy software we're still using. That's very deterministic. I get it, right? Does that do we just need to overhaul the whole thing, or do we just kind of change the way in which we interact with it? How are our operational setups or our ways of thinking, hindering us as much as we may think a piece of software is? Marrying the deterministic and the probabilistic. This gets into the, again, the role of the forecaster, which, we're still trying to find our way through and give a clear vision for. And there's, this challenge that the forecasters are a group of humans, and they have a spectrum of the ways in which they can understand this, utilize this, and that's just having a group of humans, and that's just where we are. So I don't think I have anything further. So I think I'll leave it there. And Randy, if there's any questions or comments, I'll take them.